Hi everyone, I'm very pleased to welcome you to this short win video. The introduction of fly-by-wire in the fourth generation aircraft has brought a huge improvement in terms of flight safety. Technology has significantly reduced the number of accidents over the years, but it is essential for the flight crew to understand how the aircraft system operates and of course to maintain active monitoring at all times. In this short win video, we will first review the flight control philosophy and the design objectives of the fly-by-wire protection in manual flight and the autopilot in its operation area. Then we will review the autopilot and flight control integration and specifically the normal low protections and the autopilot limit. To illustrate the flight control and autopilot integration, we will observe the behavior of the systems in case of high pitch or high angle of attack. So let's review the flight control philosophy. We have two systems and two functions for two objectives. The fly-by-wire system. It is designed to alleviate the workload of the flight crew. It will provide the maximum authority to the crew as it is an Airbus design rule and required by the certification process. It will protect the flight domain thanks to the associated protection. The protections are integrated in the flight control system. And we have the autopilot, which is designed to assist the pilot in its routine task. The gain of the autopilot, in other words, the level of authority of the flight control, is optimized depending on the expected task. For example, during an ILS final, we need high gains because we are looking for high accuracy of the system to follow the ILS signal. During the cruise, we prioritize passenger comfort and low gains are sufficient. When using the speed brakes, the autopilot must be able to maintain the vertical profile, so quick answers are required to compensate and counteract aerodynamic effects. To illustrate the previous definitions, on the left side, we can symbolize flying manually through the fly-by-wire system with a side stick by this man skating in a ball. The ball could represent the flight envelope. The skater is in a skate park with high enough sides to prevent him from leaving the safe area, symbolized by the red circle. In normal operation, this skater will always come back at the bottom of the ball, represented by the blue circle. On the right side, the skater can skate on the flight red circle. This could symbolize the autopilot area of operation. The autopilot can operate within the red circle, and if the autopilot reaches this limit, it will disconnect. Let's now have a look to a more synthetic view of the flight control envelope compared to the autopilot limit. On the left side, the skater represents the pilot flying manually through the flight controls, side stick, and rudder pedals. He is evolving within the flight envelope represented by the green ball. The inclined edge of the ball are the area where the flight control protection are active to maintain the skater within the ball. The red circle represents the flight envelope limit. It means that in normal conditions, the normal low, the man will always come back at the bottom of the ball. On the right side, the skater represents the autopilot and the flat blue disc, the autopilot operating area. The disc is flat, and when reaching the limit, the red dot circle, the autopilot will disconnect as per design. Beyond this limit, the pilot takes over manually and the safe envelope is ensured by the protection in manual flight. On Airbus 320, 330 and 340 families, the autopilot is not available when the protections are activated. For an Airbus 320, we can review the level of activation of the flight control protections in further detail. In pitch, the aircraft cannot go beyond minus 15 degrees and plus 30 degrees, 20 if it's in full in low speed. In bank, the limitation is 66 degrees, 45 degrees in case of high angle of attack. For high speed, it's limited to VMO plus 6 or MMO plus 001. And for angle of attack, it's limited by alpha max. For the autopilot, we will talk about limits. In a dynamic environment, if the system goes beyond these limits, the autopilot disconnects as per aircraft design. For the pitch, these limits are minus 13 degrees and above 25 degrees. For the bank, it's above 45 degrees. For the alpha prot, above alpha prot plus 1. For the overspeed, when reaching the limit, the autopilot will initially try to pitch up before disconnecting if normal conditions are not recovered. As we saw previously, the autopilot can operate with various gains depending on the situation. Nevertheless, the autopilot is not able to cover all the flight domain. This is why, for example, we have some auto-land limitation and the aircraft has to be flown manually above maximum crosswind limitation. So we have reviewed the flight control envelope and its protection, providing the aircraft positive stability versus the autopilot operating area within its own limit. Let's see now the autopilot and flight control integration. As we all know, we can operate the aircraft in two different ways. Through the autopilot to alleviate the pilot task during routine operations, or manual flying via the side stick and the flight control system. Back to the previous slide showing the normal low protections and the autopilot limits. For many parameters, the autopilot limit is included within the flight control protection envelope, the red line on top of the ball. But for specific configuration, for example an Airbus 320 in full low speed and glide slope mode, the autopilot will disconnect beyond the normal flight control protection envelope. When we superimpose both limits in this case, the autopilot limit is 25 degrees versus 20 degrees for the normal flight control protection envelope. Let's focus on the behavior of the autopilot when reaching the pitch disconnection threshold. In this example, we have an Airbus 320 in full low speed, glide slope mode and autopilot on. The blue line is a sectional plan of the flat blue disc, which is the autopilot area of operation. The gray area, the side view of the ball, represents the flight control laws which remain ready to take over in the background in case of autopilot disconnection. Now the autopilot will reach its 25 degrees limit. As per design, the autopilot will disconnect when reaching its operational limit. You will notice the cavalry charge and the master warning. After the autopilot disconnection, the flight control law, which were previously passive, will now take over. If the pilot maintains the full backstick input, the protection will bring the aircraft back to 20 degrees, which is the limitation for that configuration, full and low speed. If the pilot releases the sticks now, as per design, the 15 degrees limitation will be maintained to stay within the flight control protection envelope. We will observe now the same behavior for high angle of attack protection and limit. Let's focus on the autopilot behavior when reaching high angle of attack. As previously explained, the blue line is a sectional plan of the flat blue disc, which is the autopilot area of operation, and the gray area represents the side view of the ball, where the flight control law remains ready in the background during autopilot operation. So if the angle of attack reaches alpha prot plus 1, the autopilot will disconnect as per design. As per design, when the autopilot disconnects, the flight control laws, which were passive in the background, will take over and become active. Now in manual flight, the flight control system and its protection will maintain the aircraft in the normal flight envelope. When the pilot releases the stick, the flight control laws bring back the aircraft to the normal flight envelope. So in conclusion of this short presentation, the autopilot is designed to assist the pilot flying by performing guidance tasks. On Airbus 320, 330 and 340, when flying in autopilot mode, the aircraft is protected by the disconnection logic. Safe operations rely on the correct crew responses through effective monitoring. The fly-by-wire system is designed to protect the flight. The Airbus Golden Rules reminds you to use appropriate level of automation at all time and to take action if things don't go as expected. So what is the way forward? As part of a set of initiatives to get the flight safety beyond standards, it is the intention of Airbus to have the robustness of the autopilot of the 320 and the 330 as close as possible at the 350 autopilot. I hope that this short presentation will be useful for your future briefings and training sessions. Thank you for listening, and I look forward to seeing you again soon.